Good day, welcome back. Today we're going to continue with the kiln build. Last week we got all of the blocks put together, the channel cut, and the elements fed in. Today we're going to work on wrapping it all up with some K-wool and connecting some of the electronics. If you like this, please like and subscribe. And let's get to it. First up, I'm going to take an old Thermac Couble I had. It's a K-type, which means it'll handle the temperatures in the kiln. And I'm going to shorten it for the length of the fire bricks. To do that, you just simply undo the screws, pull out the wire. People are sometimes worried about shortening these, not sure if it'll damage it, but it's actually only the tip that's a bimetal strip that actually measures that temperature. So I'm just setting the thickness here for the thickness of a block, cutting it to length, and then I'm going to go put the ceramic heat temperature blocks on there just for the depth of the block. Put it back in and screw it back up. I now have a Thermac Couble that's a little bit easier to wield. It's not so long and unruly. So next we have to cut a notch in the blocks that go on the top of the kiln. And I'm just using two of the blocks, running it in the middle. And I found just this wire brush actually worked really good for cleaning out the slot and making it fit nice and perfect. Got a nice snug fit in there. And it's right here. This is what it looks like on the wiring diagram. That's the part we just installed. I've left it a little bit proud so that I can actually put the K-wool underneath it. These are all of the electrical components we're going to get installed today to actually make some heat. I've got a list of them all in the article I've linked in the description. So to start with, we're going to put the ceramic blocks on the back end of the kiln. We use ceramic terminal blocks because of the high temperatures the kiln will get to, and we can't use just a normal wire nut because it'll melt. Once we've got all the blocks screwed in, the next stage is going to be to tie this little wire between the heating elements so that the current will flow through them. I'm using 14 gauge high temperature wire. Again, the link for this wire is in the article. I'm just stripping both ends of the wire, and you get really disappointed because nobody pointed out I actually screwed this into the wrong terminal block. It should have been in the green one, not the red one. We'll fix it later. Next, we're going to connect the leads that connect actually to the power that'll power the heating elements. And again, just using some of the wire. And here's where I realized my mistake and had to move the wire to the right block. I'm going to line up the components as a test fit in the project box, and then start actually cutting some holes for the strain relief nuts that the wires are going to pass through on. With a Dremel, but it's actually pretty easy to cut the holes in the boxes. And then mark out where I want the other components. That's the PID. Close, and then again just grind them out to the right size. Once I've got all the holes cut, I decided I was only going to use one light. So I've got a switch, a light, and the PID. Next, I'm going to start screwing in the components into the box itself so I can actually start connecting the wires. All of the wiring diagrams and explanation is at the back or the end of this video, so if that's what you're here for, just jump to the end. Tighten up the strain relief. I just put in a Thermac Couble. There's the power. There's the power to the heating elements. And what I did is I very carefully went and put some tape and marked all of the connections before I started connecting it up. Once I got everything connected, I just tested it to see if everything turned on, had a look in the kiln, and I see glowing heating elements. Next, we need to start making the front door. I recessed the front door a little bit as well to try and give it again a little bit of a better seal. And then we had to start putting the uprights on so that we can actually start wrapping this whole thing in K-wool and some siding. I picked up this flashing from the Home Depot store. It's just thin aluminum flashing, and all I'm doing is measuring it and cutting it into shape. Just using some tin snips, and we end up with a piece that fits pretty nice. Then we stuff it full of K-wool, trim it up, and put the flashing on. Took a couple times going back and forth to make it fit exactly. It was a pain in the ass to work with because it's really thin stuff. I didn't want this to be too heavy, but I did want to contain all the K-wool. But it just slides in, and there we have a nice side. It's a little bit puffier than I had hoped. The K-wool was a little bit thicker, and then we'll put on some bars. For the back, I'm just going to cut a little hole in the flashing, and just to cut around the braces, and now we have a back piece. And my plan is to have the back and the side top braces only screw on, not weld on, so that I can actually pull it apart and change out any components I need to. The heating elements in these things are consumable. They do break down and you have to replace them, so I want to be able to get into it. Just welding up the front and the one side. I welded up the side that's closest where the controller is going to go. Here I'm just making a hole where I'm going to run the wire for the K-type Thermac Couble will run. And the reason I used, you might have seen, I used a plug-in. I took that wire and actually made a plug on the other end of it. The reason I did that is for right now, you'll see I want to be able to pass that plug-in through the hole and connect it when I need to. So again, a little bit more K-wool, cut to size, run the wire of the Thermac Couble up through the K-wool, trim it up, and now pull the wire through the flashing. I've basically got the whole thing wrapped now in K-wool and some aluminum flashing. I'm not that worried about temperature. I've used my wife's pottery kiln, and with the bricks, the outside's only going to get to 400, maybe 500 degrees, just the bricks. The K-wool, again, will add some more. So here's where I've only screwed on the top two members so I can take all that apart. Next, we've got a door that's going to hinge. I've made a metal frame for it. And now we're going to have to put some hinges on it. So I'm just test fitting everything, make sure it's going to fit. And I'm using these little barrel hinges. Again, there's a link to them. I really screwed up here because I put the barrel hinges on upside down the first time. Again, disappointed, nobody told me I was doing it wrong. But effectively, I just weld them on the frame. The pin should point down so that they're hanging. And here, I'm doing it exactly the opposite. So I had to go do it again. Maybe I should do a grinder. All right, now that I've got them on the right way, once we've got it welded up, we hang the door, and what do you know, it opens. Now I'm just using some mortar again to make sure I can seal that front door in. So I've sealed the aluminum flashing, the bricks, and I have a door. This is where I'm going to mount the control box. I haven't mounted it yet, or the limit switch, because I've run out of time for the day. I will put a handle on next week and the limit switch, but for right now it is functional. I could technically use it, but again, the day's done. It's time to move on. And lastly, I do want to grind it and use the fancy black and gold paint before I actually go forward and heat treat something. First, a disclaimer, I'm not an electrician. If you are unsure at all about this, get some help from somebody that knows what they're doing. This is 220 volts and it can kill you. So how do we get heat? We're going to use a PID temperature controller. Stands for Programmable Integral Derivative Temperature Controller. It's going to control the current through an SSR, a solid state relay. The SSR is going to get very hot, so we're going to control its heat with a heat sink. The current is going to flow through our heating elements, and they're going to get hot and heat up the kiln. Lastly, we're going to control the temperature with a Thermac Couble designed for high heat. Altogether, it looks like this. Power is going to come in through our plug-in, 220 volts. The power is going to flow through a switch with a red light indicator to show the power's on. The power will also flow directly to our heating elements, causing the heat. We're going to wire pins 3 and 4 directly to our thermocouple to control the temperature. This is dependent upon the positive and negative, so if you get it wrong, you might have to switch it. Next, we're going to run our power through our switch and put in a red light in line just so we can see when it's turned on. We're going to run one side of our power directly to our heating elements and the other side directly to the switched side of the SSR. The SSR has two sides, one that controls whether or not the switch is open or closed, and the other one is actually the power through the SSR. Pin 6 of the PID goes to the control side of the SSR. Pin 8 also goes to the control side, but through a limit switch that we're putting on the door so the circuit turns off whenever the door is open. Lastly, we connect the power from the other side of the SSR through to the heating elements, and we have heat.